Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello everyone. And welcome to our discussion today. Let's begin by exploring the significance of using large language models in the legal domain. What makes these models particularly suitable for handling extensive and complex legal texts?
Large language models, LLMs, are like smart robots that can understand and generate human language. In the legal world, they are particularly useful because they can handle very long and complex documents. Just like a librarian can organize a big stack of messy books, legal documents often don't follow a clear pattern, and they can be as long as a long storybook, sometimes with more than 10,000 words. This jumble makes it hard for humans, even skilled legal professionals, to quickly find and understand the important parts. It's like trying to find a needle in a haystack when the haystack is huge and all mixed up. LLMs can help by breaking these big documents into smaller, more manageable pieces, kind of like slicing a big cake into smaller slices so you can enjoy it more easily. By doing this, they can recognize patterns and relationships within the text, helping to predict outcomes of legal cases more effectively. Additionally, using a specialized structure, like the hierarchical framework we explore, makes it even easier for these models to learn and understand the different parts of legal document. This combination of LLMs and structured approaches allows us to tackle the complexity of legal texts, just like a well-organized bookshelf makes it easier to find the book you need.
Thank you for that insightful explanation. Building on that, could you elaborate on the specific structure of the hierarchical framework, called MESc, and how it integrates the use of large language models to enhance the classification of legal documents?
The hierarchical framework, called MESc, which stands for Multi-Stage Encoder-Based Supervised with Clustering, is designed to tackle the challenges posed by large and complex legal documents. You can think of it like a multi-layered cake, where each layer serves a specific purpose to create a delicious final product. Firstly, the MESc framework breaks down a legal document into smaller parts, much like slicing a large cake into smaller pieces. This is helpful because it allows the system to focus on manageable sections of the text instead of trying to digest the whole document at once. Within this framework, embeddings are extracted from the last few layers of powerful large language models, LLMs, like GPT-Neo or BERT. Imagine these embeddings as unique fingerprints that capture the essence of each part of a document, helping the system understand its contents better. By combining these fingerprints from different layers, MESc can create a more complete picture of the document's structure and meaning. Additionally, MESc uses unsupervised clustering to approximate the structure of the document. This is like grouping similar pieces of cake together based on flavor or frosting type, which helps in identifying the different sections of the legal text. Once the parts are organized, the framework learns how these sections relate to each other using additional transformer layers. The beauty of this hierarchical approach is that it performs better than using LLMs alone, especially when dealing with long documents where the important sections are not known in advance. By providing a structured way to classify and analyze the text, MESc enhances the ability of LLMs to predict legal judgments, addressing the problem of long, unstructured legal documents much more effectively.
That's a fantastic analogy. Now, could you discuss the experimental methods used to evaluate the MESc framework, including the datasets involved, and how the results were compared to previous state-of-the-art classification methods?
The evaluation of the MESc framework involved several experimental methods that tested its effectiveness in classifying large unstructured legal documents. Imagine it as a science experiment where different ingredients are tried out to create the best recipe. To start with, the researchers used two main datasets, LexGLUE and ILDC. Think of these datasets as a variety of different legal cases that needed to be solved. They provided a rich source of information for training and testing the MESc framework. The MESc framework works by extracting unique fingerprints, or embeddings, from the last four layers of various fine-tuned large language models, like BERT, GPT-Neo, and GPT-J. This is akin to gathering different flavors from multiple cake layers to create a well-balanced cake. By combining these embeddings, MESc aimed to improve its understanding of the document structure, which is essential for making accurate predictions. To evaluate performance, specific measures like micro-F1 and macro-F1 scores for the LexGLUE dataset and accuracy percentage for the ILDC dataset were used. These metrics help to assess how well the framework is classifying the legal documents, similar to grading students based on their test scores to determine how well they've understood the material. The researchers also compared the results obtained by MESc against previous state-of-the-art classification methods, which helps to show how much better or different the new framework is. They found that the billion parameter LLMs, like GPT-Neo and GPT-J, performed well in these tests, especially when focusing on specific legal domains. This highlights the adaptability of the model, much like a chameleon changing color to match its surroundings. Through these experiments, the MESc framework achieved new benchmarks for the classification of legal documents, proving that it could outperform other methods, especially with long documents where the important parts might not be immediately clear. Future studies aim to further analyze the clusters created within this framework and how they contribute to making predictions, which could lead to even greater insights in legal document classification.
Thank you for that detailed overview of the evaluation process. Can you explain the significance of the performance gains achieved by the MESc framework? Particularly the studied minimum total performance gain of approximately 2 points over previous methods, and what this means for the future of legal document classification.
The studied performance gain of approximately 2 points by the MESc framework over previous state-of-the-art methods is significant for several reasons. You can think of this gain as a small but crucial step forward on a long journey. Firstly, achieving even a slight improvement in performance can have a big impact in the legal domain, where every detail matters. Legal documents are often complex and lengthy, and even small enhancements in classification accuracy can make processes more efficient. This could mean the difference between a timely judgment and further delays in case resolutions, which is particularly important given the backlog of legal cases many countries face. Moreover, this performance improvement reflects the effectiveness of the hierarchical structure of MESc. It shows that by breaking down documents into manageable parts and using embeddings from multiple layers of large language models, the framework can extract more relevant information. This is like having a magnifying glass that helps to see tiny details that would otherwise be overlooked. The ability of MESc to adapt to different legal systems, such as European and Indian cases, while outperforming previous models, suggests that it can serve as a more flexible and accessible tool for legal professionals. This could lower the barriers to using advanced AI technology in legal contexts, especially in regions with limited resources. In the future, these performance gains can pave the way for further exploration in legal document classification. Researchers can build on this foundation to analyze clusters of information, develop explanation algorithms, and improve understanding of how different sections of a document contribute to predictions. Overall, these advancements signal a promising direction for the use of AI in law, suggesting that tools like MESc can enhance the efficiency and accuracy of legal research and judgment prediction, ultimately benefiting the entire legal system.
That's an excellent perspective on the implications of these performance gains. To wrap up our discussion, could you share your thoughts on the potential challenges or limitations that might arise when implementing the MESc framework in real-world legal settings, and how those challenges could be addressed?
Implementing the MESc framework in real-world legal settings does come with potential challenges and limitations, much like navigating through a dense forest, where obstacles might block the path. One major challenge is the complexity and variability of legal texts. Legal documents often have a non-uniform structure, complicated syntax, and specialized vocabulary. This is different from general texts, which can make it difficult for the framework to accurately interpret and classify documents without proper context. To address this, enhancing the training data with more diverse legal documents from various jurisdictions could help the framework learn to handle different styles and terminologies. Another challenge is the reliance on embeddings from large language models, LLMs. While these models can adapt to various legal contexts, their performance heavily depends on the quality and quantity of the training data. If the data is limited or not representative of the legal landscape, the model may struggle. To overcome this, continuous improvement and fine-tuning of the models with domain-specific data will be crucial. Moreover, there will be ethical considerations and risks when using such automated systems. The framework should not be seen as a replacement for human judgment, but rather as a supportive tool for legal professionals. Proper training for users and clear guidelines on the limitations of the predictions made by the framework are necessary to avoid misuse. Finally, the predictions generated by MESc should be viewed cautiously. They are not foolproof and shouldn't be used to make critical legal decisions without professional oversight. Future work should focus on developing explanation algorithms to clarify how predictions are made, which can assist legal professionals in understanding the reasoning behind the model's outputs. By addressing these challenges through careful data management, user training, and transparency in how the framework operates, the MESc framework can be effectively integrated into real-world legal settings, ultimately enhancing the efficiency and accuracy of legal document classification.
Thank you all for joining us today. I hope you have found this discussion on large language models and their applications in legal document classification informative and engaging. As we have learned, LLMs are powerful tools that can handle complex and unstructured text, making them well-suited for classifying legal documents. The MESc framework, which combines LLMs with a hierarchical structure, further enhances classification accuracy by breaking down documents into smaller parts and using unsupervised clustering to approximate document structure. Evaluation on various datasets has demonstrated the improved performance of MESc over previous methods. This framework has the potential to revolutionize legal document classification, making it more efficient and adaptable to different legal systems. While challenges remain in implementing MESc in real-world settings, ongoing research is addressing these limitations. With continued progress, we can expect to see the effective integration of this framework in legal domains, leading to significant advancements in the field. Thank you again for your participation.